I need to write a proof, and I am given that K is parallel to L, and I need to prove that angle 1 is congruent to angle 2. Well, the nice part is we're already giving parallel lines. So let's go ahead and make our 2 columns. And we'll have our reasons. I should actually have my reasons over here. And my statements over here. All right, my first step is just the given. It is K is parallel to L. The reason is given. Grant, do you have a question?
Oh, no, problem.
Oh, you got my next step. What should I do next?
Angle 1 is congruent to angle 3 because of corresponding angles.
Angle 1 is congruent to angle 3 because of corresponding angles. Would that be the converse, or would that be the postulate? Yeah.
It'd be the converse because you're already given the concept. Or no. It'd be the corresponding angles, like just right.
Regular postulate, yes. Okay, oh good. Because the converse would prove they're parallel, but I'm already given it, so I'm going to use the postulate. All right, what would my third step be? Who's got my third step? Yeah, see.
3 and 2 are equal.
Angle 3 is congruent to angle 2, and why is that?
They're vertical angles.
Yeah, so the vertical angle theorem. And what is my final step? Aryan.
Angle 1 is congruent to angle 2 because of transitive.
Yep. Angle 1 is congruent to angle 2 because of the transitive property. Questions on that? Sam, do you have a question on that? Okay. Substitution could have worked for the last step, but transitive is the better of the two. All right, then let's quickly go into questions from the homework. Questions from the homework. 11, number 11 says, in a pentagon, PQRST, we have angle P equals 60 degrees, angle Q equals 130. If angles S and T are 3 times as large as R, then what is the measure of angle R, S, and T? So what I did on this one, and I'll walk through the steps on here, is I said, well, okay, a pentagon has 5 sides. A pentagon has 5 sides. So that's what I wrote right here. I said, okay, we have 5 sides. So to get the sum of all my interior angles, I just take 5 minus 2 times 180 to get to 540. That would be the total sum of the angles. What that means is, if I add up every single angle of the interior, it's going to add up to 540. So I set that up. I said P plus Q plus S plus T plus R equals 540. Then I put the information that I knew about it. Well, one of the angles was 60 degrees. One was 30 degrees. And then it says 2 of the angles were 3 times as large as that last angle. So I just replaced them with 3 times an angle, 3 times an angle, and then I just put the angle. That's where I got 3x plus x equals 540. Then I solve for x to get my 50. Then I just plug it into the different 3x's, and the x. Tori, is that good enough, or do you want me to explain something? You sure?
Yeah.
Okay. Other questions? Yeah.
For something like number 5.
Yeah, let me look at number 5. Okay, yeah.
Like, are you allowed to use the rule that says all the angles of a circle add up to 360 degrees?
Yes.
Oh, we can use it.
Yeah.
Oh, okay. I thought we weren't allowed to use it.
Yeah, no, you are 100% right. So let me take a picture. Tori, you okay with this? It is online too, so as long as you know the method of it. So let's take a picture of 5. So yeah, absolutely on 5, that can make things easier. Because I think you're looking at over here, right?
Yeah.
Yeah, that has to equal 360. So you just do 360 minus 108 minus 130, and that equals that 122. So yes, you can absolutely use that. Yeah. Number 6. There we go. All right, number 6. Did you get J? Okay. So we'll do it kind of from the beginning. Okay, you did? What'd you get for J? 120. So, okay, so we got J. We have J equals 120 degrees, and this is 120 degrees. All right, well, actually we don't need much more information than that. Do you see these lines here? That means it's parallel to this. So if I look here, this is 38. So K also has to be 38 because it's alternate interior. But you could have not known that. You could have said, well, this is 60 degrees, and this is 120, and then you could have figured out that, and you could have said, well, this has to add up to 360. So there's a couple ways to do it, but alternate interior is probably the easier of the two ways. That's why I threw some parallel line ones in there, because it's sometimes we get bogged down in this stuff, and all of a sudden parallel lines show their head on the test, and you're just like, I don't remember what to do with these. So they are embedded. In the homework tonight, there will be parallel lines too, so you can practice it that way. Other questions? Yeah.
So do the exterior angle, or does one exterior angle of a polygon equal like the other two remote angles?
No, that's just a triangle. That's just a triangle. But we're going to talk about remote exterior angles today and a trick with those. No, but a remote exterior angle with a polygon outside of a triangle is just going to be a linear pair with the interior angle.
Yeah.
Other questions? Okay. Today we're going to talk about the exterior angle measures. The exterior angle measures. And I do want to talk about the fact that they are linear pairs. So if I knew this was, say, 120, this would be 60 degrees. So these are always linear pairs. But we're not worried about numbers here. We're just saying we have a pentagon. And I look at an exterior angle. Then I look at all of the possible exterior angles. That would be 1, 2, 3, 4, 5 exterior angles. If you pulled all those off, that's what I did here. I pulled all of them off, and I taped them all together. They make that circle that you brought up earlier today. So how many degrees this would be? Would be 360 degrees. It'd be 360 degrees. Let's double check that. Let's pretend this is a regular polygon. This is a regular polygon. Can someone tell me how to get the measure of an interior angle of a regular polygon? Sam.
You take away it. The 180 minus x.
180 minus. You would. But I'm saying, can we actually, if I say that's a regular polygon, I'm going to say that's a regular pentagon. I want an actual number for one of the angles of the pentagon. How would I do that? How would I get the actual number value of that? So like I said, it was a regular pentagon. So that means all of your angles are congruent. How do I get that? Yeah.
You would take the number of sides.
Yep.
Shape I. Subtract 2. Then the sum of those, or the difference between those two numbers, multiplied by 180.
By 180,
Yep.
which is going to equal 540.
And then you divide 540 by 5 because all the vertices are.
Yeah. So one angle is going to be 540 divided by 5. How many angles you have? And what do we come up with that? I was going to do 540 divided by 5. And you can use your calculator. Spell? 108 degrees. All right, so if that's 108 degrees, then this one's going to be 72 degrees. And there are 1, 2, 3, 4, 5 of them. What is 72 times 5? CC? Equals 360 degrees, so it does work. And it will work with any polygon. It'll work with any polygon. And in fact, that's where we came up with the exterior angles theorem. The exterior angles theorem says the sum of the measures of the exterior angles of any convex polygon is 360 degrees. So here's our key words. Exterior angles, sum, polygon, 360. Those are our key words. The exterior sum of any polygon that we're going to deal with in this class. I know it says convex, but that's all we're dealing with in this class. So what that means to you is any polygon that I talk about the exterior sum, you're going to immediately say that's 360 degrees. So if you add up every single exterior angle, they're going to add to 360 degrees. Yes?
For the exterior angles, like with this one, you can like extend it like both ways.
Once you pick one direction, you have to pick it up the same on each of them.
Oh, okay.
So yes, I get what you're saying, that you could draw an exterior angle that way. But there's only one exterior angle that I want to look at for each of these. All right, don't pick two of them. All right, it's always one per. There's one exterior angle that we can look at per time of any interior angle. All right.
The theorem for
Mhm.
polygons, should it go under like the triangle that we have?
If you want to, that backside is yours to write any theorems and stuff you want to write about the theorems. Yeah, that's what I brought up yesterday, right? Grant.
Is the exterior angle theorem with the triangles the same thing as this, kind of? Because, like, a triangle, did we count that as a polygon?
Our triangle is a polygon. That would work with this. Yeah. So if you got the exterior measures of a triangle, it's going to add up to 360 degrees. In fact, we did that for homework. If you remember, there was a hard one that I said like measure of angle 9 plus measure of angle 8 plus measure, and you came up with the two remote. It turned out to be 360 when you added them all up. All right, so that means find the sum of the measures of the exterior angles of a polygon with 32 sides. So once again, I see sum. I see exterior angles. Sum of exterior angles is always 360 degrees. All right, the next one's a little tougher. What happens if I have 329 sides? And you can use your calculator for this one. You shouldn't have to. I don't want to scare you, friend. 360 degrees. Because once again, I'm looking at exterior angles and sum. Real quick though, does that mean each exterior angle equals 360 degrees? Grant?
No.
No, it just means the sum. When you add them all up, they equal 360 degrees. All right, we're going to do a problem using exterior angles. It says, how many sides does a polygon have if each interior angle measures 135 degrees? So I'm going to write something real quick. So we have interior angle is 135 degrees. If my interior angle is 135 degrees, what is the measure of my exterior angle attached to it? And here's my hint to you. This is an interior measure of 108. What did I have to do to get the exterior that was paired with it? Yeah, it would be 45 degrees. And that is because an interior and exterior, I didn't really leave room for it, are going to be linear pairs. All right, our exterior angle is 45 degrees. What happens when I add up all my exterior angles? What does that equal? 360, thank you. So if one of my exteriors is 45, I know when I add them all together, they equal 360. So you just have to figure out how many times you have to add 45 to equal 360. In other words, all you have to do is 360 degrees, which is your sum of exterior angles, divided by 45 degrees, which is one angle, that's going to equal how many angles you have. And what does that come out to? What is 360 divided by 45? You can use your calculator. I just need 360 divided by 45. It is 8. It is 8. So that 8 is really the number of exterior angles and the number of interior angles and the number of sides. So we have 8 sides, and we use the exterior angles to find those. That's the easiest way to do this problem. So once again, they give me an interior angle. I find out the exterior angle is 45. I know when I add all the exterior angles together, they need to equal 360. So I take 360 divided by 45, and that comes up with 8 exterior angles. But that means I have 8 interior angles, which also means I have 8 sides. Questions on that? Okay. Please ask now. We do have a test on Tuesday. All right, let's talk about regular polygons. We already talked about this. I just want to make sure you wrote it down and you pay attention because it is important. A regular polygon is equiangular and equilateral. And so that just means both. Both are occurring. Remember I say regular, just know all the angles are the same and all the sides are the same. All right, the last thing we're going to do is we're going to find, so we're given a regular polygon that has 6 sides. So it's a hexagon. It's a regular hexagon. It says find the measure of each interior angle using 2 different methods. The first method we're going to use is using our information that we know about interior angles. The other method is going to be we're going to use our exterior angles sum to come up with what one interior angle equals. All right, so just remember we have a 6-sided figure. So if I'm using interior angles sum, the first thing we're going to do is do our interior angle sum, where we do our sides minus 2 times 180. And that's going to be 4 times 180, which is 360 plus 360, which is 720. Why did I do this? Because we were given that it's a 6-sided figure, and I know I have to do something to figure out the angles. So I need to find an individual angle. So the only thing I know about interiors and angles is this formula, that I can get the total sum.
Oh, that'll give you the sum.
That will give me the sum. Yeah, so this is going to be 720. That is the sum of all interior angles, right? But it wanted the measure of just one angle. So what do I do with that entire sum? Yeah.
You just divide it by 6.
Divide by 6, because 6 is the number of sides, which is the number of angles. So we'll take that total sum and divide it by 6, which is the number of angles that you have. And what's 720 divided by 6? Someone. We're really slow today. Isabella, thank you. 120. Forget all this. We're going to pretend like we didn't do this. We're going to use exterior angles to come up with the measure of one interior angle. All right, we are going to use the exterior angles sum to come up with how many angles we have. All right, so first of all, When I add up all the exterior angles of any polygon, they equal, shout it out. What does it equal? 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 Some people still aren't saying it. What does it equal?
360.
What does it equal?
360.
Okay, 360. You guys are just it's amazing. All right, 360, which is the sum of all exterior angles. How many exterior angles do we have? If I have 6 sides. If I have 6 sides, how many do you have? 6 exterior angles, right? So we have 6. That's the number of exterior angles. So to figure out how many, what each exterior angle equals, we're just going to do 360 divided by 6, which equals 60 degrees. So that is the measure of one exterior angle. Then I'm going to do a very quick drawing so we can see what's happening here. So I'm going to draw a 6-sided figure. Make it as regular as possible. That is my 6-sided figure. And I'm going to draw an exterior angle. An exterior angle is always going to be a linear pair, so you just draw a straight line. If this exterior angle is 60 degrees, what's the interior angle attached to it? What is that interior angle attached to it? JK?
The interior angle is 120.
120 degrees, because it's a linear pair. So that's just going to be 120 degrees, which is what we got over here. Is one method easier than the other? I don't think so. I think they're both about the same amount. But you need to know how to use both methods, because sometimes one will be easier than the other. Yes?
Can you explain again why you did 360 divided by 6?
Yeah. So you're with me that 360 is the sum of all exterior angles, right? Do you agree that 6 is the number of exterior angles that we have?
Yeah, because there are 6 sides.
There's 6 sides, there's 6 interior angles, which means there's 6 exterior angles. So if you take 360 divided by the number of exterior angles you have, you come up with how much each exterior angle equals.
Okay.
So each one's going to be 60. So when you go 60 plus 60 plus 60 plus 60 plus 60 plus 60, it should equal 360. And once I figure out that each exterior angle is 60 degrees, I just put in there and know that it's a linear pair to the interior angle. So my interior angle is 120 degrees, and that's what we started off wanting to know. What does each interior angles measure?
Oh, okay. Okay, yeah.
So we kind of went to the outside to come back into the inside.
All right.
It's just a method you can use.
Yeah.
I'm just showing that both come up with the exact same answer.
Okay, and then on the other side, you found the sum of all the angles, all the interior angles divided by 6.
And divided by how many angles you had. Yep.
Yeah.
So both of them are basically how many angles you have, divide that sum by.
Okay.
The second one's kind of nice in case you forget that formula. And you're just like, okay, I know exterior angles are 360. I know I can use this. All right, the rest is your homework. So that 1 through 6, starting on this page. Quick hint, number 2 and number 3 will have decimals.
So when we do the math, should we do it with that?
Just either leave it as a fraction, as you could do in 2. 2 could be a fraction, or just round to the 10th place. All right, so round it to the 10th place. Quick 2, you got 2 things today. You have your lesson, which has the homework attached to it, and you also got a review. The review packet is not due on Monday. So I don't want you staying up till 5 in the morning, Monday morning, trying to finish it for class. I'm not going to check it on Monday. Why I give it to you now is because if you get done with your homework, it's always a good idea. I mean, if you get it done, awesome. You just have so much free time on your hands. Awesome. But why I give it to you is more likely you don't have a ton of time. Just look it over. See things that might cause problems to you. Maybe try a couple problems. That way on Monday when I start the class and I say, do you have any questions? You can ask questions on the review right away. And then you'll just have the rest of the time to work on the review.
Does the review due Tuesday?
Review is never due. I never collect it, but I know if you did it or not because remember, so what I typically do is I write the test, then we kind of write the lessons, and then I write a review based upon all this stuff. So my review is, I think, the most important stuff. It's not going to be 100% what's on the test, but I generally know if you did the review and you understand it, you generally do well on the test. That's where I see if you did it or not. Okay? But I don't collect it. It is on you to do it. Any questions for me? All right, then the rest of the